Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very nice equation with complex numbers, a homemade equation with complex numbers. What is a complex number? Z is a complex number. It can be written as A plus BI. A and B are real numbers. I is the square root of -1, or we can write it as I squared equals -1. Which is a better version. Because when you say the square root, there are two square roots, one of them is principal, so on and so forth. Anyways, there's a lot of details that I'm not going to go into because I made lecture videos. If you're new to complex numbers, go ahead and check them out. So we have this type of equation. Z is a complex number. I is imaginary. So we raise a complex number to an imaginary power and it becomes real. Wow, that's interesting, right? If you've seen this before, don't give it away. Let's just go with the flow. So, how do you solve an equation like this? There's a couple things we need to talk about. One of them is the complex exponentiation. We can also talk about the natural log or the logarithm of a complex number, so on and so forth. Complex exponentiation, the polar form, and all that's fun stuff. So, when you raise a real number to a real power or an integer to an integer power, it's fairly easy. Like 2 to the third power means you write the 2 3 times and multiply, that's 8, right? Easy. Don't say 2 times 3. Some people say that. Okay. But with rational numbers, things are a little different. This means square root of 2 in the real world. And then when you have something like 2 to the power root 5, that becomes a little interesting. You can approximate root 5 and look at the rational approximation, so on and so forth. Anyways, these are easy cases. But when it becomes a complex number to a complex power, then things get really crazy. So here's what we're going to do. We're going to go ahead. First of all, I told you that Z equals A plus BI, right? That solves a lot of problems. It's also the name of this channel, in case you didn't know. So does it help if you replace A with Z, Z with A plus BI, then raise it to the power I, and this becomes a real number, right? How do you handle this? This is quite complicated and very complex. So you can natural log both sides, but then you kind of need to talk about the natural log of a complex number. Let's go ahead and do it this way. I want to write Z to the power I as e to the power I ln Z. Because that's how it's defined. In general, Z to the W can be written as e to the power W ln Z. Now, and then the next thing we need to talk about is how do you ln a complex number? To ln a complex number, basically a complex number can be written as r times e to the I theta, where r is the modulus or the absolute value, and this is the argument of our number. So ln of a complex number is ln r plus I theta, where theta is the argument, r is the modulus. Make sense? So make sure you memorize these two formulas because they're always used. And very, very easy to remember, by the way, right? They're not complicated. So let's go ahead and apply it. And when we apply this to our situation, z to the I just becomes e to the power I times ln r plus I theta. We could even come up with a single formula that'll give us z to the I directly, but that's not necessary. Know these two things, especially, I think this one is probably not the one you would be memorizing because I think this is a more general form, so let's go ahead and use this. So these two, okay? And of course, I just said theta, but theta can be the principal argument, and you can also add multiples of 2 pi to it. Make sense? Okay. So let's go ahead and do it for this number. What is the modulus of z? We don't know, right? So we kind of need to do the following then. Let's just use this and plug it in and see what happens with the givens. Great. So we have z to the I equals e to the power pi over 2, right? Okay. Now, we're going to go ahead and replace z to the I with this. That'll give me e to the power I times ln r plus I theta. And then this will give me e to the power pi over 2. Nice. Let's see what happens from here. We can go ahead and distribute e to the power I ln r. And then I times I is I squared. Like I told you earlier, I squared is -1. So this is just going to be minus theta equals e to the power pi over 2. Nice. But how do you handle something like this? Easy. You just natural log both sides and set them equal to each other. I ln r minus theta is equal to pi over 2. Now we have two unknowns, but don't worry about it because we have complex numbers on both sides and we're going to be able to solve for r and theta at the same time. So because this is kind of like a system of equations. Now the left-hand side, and let's go ahead and write it if you want. You can also write it like this, so it's more it's more in the standard form. And now you can go ahead and compare. So if two complex numbers are equal, then their real parts are equal. So negative theta needs to be pi over 2. That tells you that theta is negative pi over 2. Of course, this is not the only solution, but I'm going off of the principal value to keep things a little simple. I can also show you the general form. And then the imaginary part, on the right-hand side, we notice that we have 0i. So the coefficient of I needs to be 0, which means ln r is 0. You got to remember, r is real and non-negative, right? So from here, we get immediately r equals 1. Nice. Now, remember, we are able to write z as r e to the I theta. So r is 1, theta is negative pi over 2, so I can kind of put the negative here, and that will be my solution. But what is that supposed to mean? What is r e to the I theta mean? Well, you can kind of write it as r times cosine theta plus I sine theta, because that's what e to the I theta is. Thanks to Euler, we have a beautiful, beautiful, beautiful formula. The most beautiful equation in the world, right? And anywhere else. So this gives us an idea. Of course, we can now write this as cosine of negative pi over 2. Don't forget, the argument is negative here. And of course, cosine is even, so it'll absorb the negative, but sine will have to spit it out. So this will be cosine pi over 2 minus I times sine pi over 2. And then, of course, this is all z. And z will be, what is cosine 90 degrees? 0. You know that, right? And sine pi over 2 or sine 90 degrees is 1. So the answer is negative I. But again, this is just a single solution. Let's go ahead and look for the general solution. So how could you find all the possible solutions? Well, you kind of approach this problem a little differently maybe, right? Let's go ahead and take a look. We have z to the I. Maybe we'll call this the second approach, or just finding all the solutions, whatever. Now, first of all, you got to think about it this way. If z is a plus bi, where it has a real part, like a is not 0, then you're going to run into a problem. Because it's that number to the power I is not going to be real. How do I know that? From experience. But here's what we can do. We can go ahead and write this as e to the power I ln z again, and e to the power pi over 2. And then from here, we can actually try the following. I ln z is equal to pi over 2. So ln z is just going to be pi over 2i. What I did was basically replaced, divided both sides by I. That's what I did. Now I'm going to go ahead and multiply. Actually, that doesn't really fit the method that I normally use. I'll multiply by negative I. That's better. You'll see in a little bit why. And these two cancel out because negative I squared is 1. ln z is negative I pi over 2. Does that look familiar? I hope it does. Now from here, we're going to do the following. Z is going to be e to the power negative I pi over 2. But here's the thing. We can go ahead and write it in a more general form, and this is how it is. If you replace pi over 2 with pi over 2 plus 2 pi n, this equation would still be correct. You know why? Because this would be e to the power negative I pi over 2 times e to the power negative 2 pi ni. Now, e to the power negative 2 pi ni is the same as e to the power 2 pi ki, whatever, and this is just one in the complex word. Because if you think about it, we have a complex number whose argument is 2 pi or any multiple of 2 pi, which is equivalent to 0, so it'll always be 1. because its modulus is 1. Make sense? So in general, this would be the solution. So from here, obviously we get that, but if you want to write the more general solution, it's going to be e to the power negative I times pi over 2 plus 2 pi n. Do you want to write it in the cosine sine form? That's fine. You can do so, but again, you're going to have to include n there, right? Will you? Anyways, this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. By the way, I'm sorry, I included the wrong one. So sorry about that. Maybe Wolfram Alpha would be able to solve this problem. That was from a previous video. I guess I apologize. But anyways, see you next time. Bye-bye.